Okay, welcome back, you guys. We are going to be talking about our last two exponent rules today. The first one being our negative rule. Okay, so today you might notice if you're looking ahead into our notes, you're going to see that there are exponents that are actually negative exponents, right? So looking in number 2, I see a 3 to the power of negative 3, another 3 to the power of negative 3. Okay, well, we are going to learn what we actually do when we have negative exponents, okay? So first of all, let's define negative rule. Okay, so let's say I have x to the negative second power. Okay, so what happens? How do we fix it? We need, in order to simplify these expressions, we have to make sure that all of our negative exponents are gone. We have to turn them into positive exponents. Okay, so here's what happens. So we are always in every single whole number, there's always over 1. Anything. Okay, any whole number, there's always an invisible over 1, just like 1 is always that creepy number. Okay, well, here's what happens with our negative exponent. So the negative exponent grabs only what it's attached to. So in this case, it's the x, and then it switches sides, meaning this time it went from our numerator to our denominator. Okay, well, since it grabbed it and it put it on the bottom, what's left on top? Hint, it's the creepy invisible number. You got it, it's 1, and when our 1 is on top, we have to write it. And since x to the negative 2 moved, it now becomes positive. Okay, we don't need to write that 1 anymore because 1 times anything is just itself. Okay, so whenever you see a negative exponent, you're going to think switch. Meaning, if that negative exponent had been on the bottom, if our x to the negative 2 had been on the denominator, then it would have switched to the other side, the numerator. Okay, but that's all it is. We are just switching. Awesome. So let's do a couple examples now. So we notice on number 2, let me zoom in a little bit. Okay, so we notice on number 2, first thing we want to do is we want to find the negative exponents and we want to circle what it's attached to. Okay, so I see a 3 to the negative 3. Yep. So this negative 3 is only attached to that 3. Holy cow, there's a lot of 3's in this problem. Okay, so I see a 3 to the negative 3 right there, and I see a 3 to the negative 3 on bottom. Okay. Well, this 3 to the negative 3 is going to move from the numerator to the denominator, and this 3 to the negative 3 is going to move from the denominator to the numerator. Okay, it's switching. Remember, negative, think switch. Okay, so let's rewrite it. So on top, I already had that 3 cubed, or 3 to the positive 3. Okay, now that one on bottom moved to the top, and now it is positive. So now it's 3 to the positive 3. Okay, same thing right here. That 3 to the negative 3 on top moved to the bottom, and it also became positive. So again, 3 to the positive 3. Okay, we are not done simplifying. I see 3 of the same bases. Okay, but I also see a rule that you can always use. Remember, maybe it was 2 times ago, but I'm sure we've talked about it again. Anytime you see something over itself, okay, what happens? What happens when there's something and the exact same thing is on bottom? Something over itself. They cancel, right? So I can say 3 cubed over 3 cubed. You also could have taken that 3 cubed. Doesn't matter. They're all 3 cubed. And we simplify what's left. Nothing's left on bottom, so we don't have to write the bottom. The only thing that was left was 3 cubed. And there we go. Okay, let's look at number 3. Okay, so first thing we want to do, let's find our negative exponents. So I see one negative exponent here. Okay, 3 is trying to kind of confuse you guys a little bit. Okay, so these parentheses, this is something that we should note. In fact, I'm going to make a note on my paper. Okay, let's write a little note on the side. Parentheses means everything inside. Okay. So these parentheses, the exponent is attached to everything inside the parentheses. Okay, so I see a -3 exponent right here. So it's attached to all of that since there's a parentheses. Okay, so now that -3 exponent is going to make it switch from the denominator to the numerator. Okay, so let's rewrite it. We'll rewrite it down here. Give me some space. Okay, so what about this -3? Does that move? Notice all these negatives. Okay, they don't move, right? Only the negative exponent will move. So we had, that was already on top, a -3 squared. Okay, now we have a -3 to the +3. Okay, that's what moved into our numerator. Okay, on bottom, I see a -3 squared. Okay, do you guys see anything in number 3? See the same thing that we did in number 2. Okay, what can happen when you have something over itself? Okay, something exactly over itself. I see a -3 squared over -3 squared. It can cancel. Okay, so the only thing that's left, our answer on top. We don't have to write the denominator because there's nothing left on bottom. So our answer is -3, cubed. Perfect. Okay, let's look at number 4 because there's something new about number 4 as well. Okay, so we're going to follow the same steps. Look for your negative exponent and then switch sides. Okay, so the only negative exponent I see is this -3. Okay, so let me ask you this. Is this -3 attached to the m or the -m? Hint, do you see any parentheses? Any of these guys? Do you see any parentheses? No, you don't. Okay, so this -3 exponent is only attached to that m. Okay, that negative sign is technically, I'm going to rewrite it, that technically means -1 times m to the -3. Okay, so it's only attached to the m. It only moves that m. So it moves from the numerator to the denominator. Okay, so now let's write it out. The only thing I have left on top is that -1. Okay, on bottom I have a -2 m squared times m that was already there. And now times m, it was -3, but now it's +3. Okay, so we're not quite done simplifying. Okay, this is not our simplified answer. So the first thing I see, now we are going to have to use more exponent rules that we've already learned. So one thing I see on bottom is that I see a lot of m's being multiplied together. Okay, there's 2 m's right there. There's 1 m right there. And then there's another 3 m's right there. How many m's am I going to have left on bottom? Okay, how many m's is that? 2 plus 1 is 3. 3 plus another 3 is 6. You got it. So I have m to the 6 on bottom. Okay, the last thing we need to simplify, again, I see something over itself. I don't see, it's not -1 over -2, but what about these negative signs? Those count, right? Those are the same things over itself. So we can say, oh, negative over negative, or you can also think a negative divided by a negative is going to be a positive, so they get rid of that negative. Okay, so the only thing that's left is that 1, I'll write it in green, that 1 left on top, and that 2 left on bottom. Okay, now we are simplified. Okay, I only see one m, I see 1, 1, and 1, 2. Perfect, we are simplified. Okay, let's look at number 5. Okay, same first step, find your negative exponents, and we need to move them. Okay, be careful what they're attached to. Remember, if there are no parentheses, they're only attached to what's right in front of them. Okay, so I see this -2 exponent. So it's going to grab that x right there. Careful, not the 3. Okay, it's only attached to the x. Same with this -1 exponent. It's only attached to the x, not the -2. Okay, so they're both on bottom. So they both move to the top. Okay, so now we can rewrite this. X cubed was already there. So we have an x cubed. Now it's being multiplied by x to the negative second power is now x to the positive second power because it moved. X to the negative first power is now just x to the positive first power. Okay, and on bottom we have a 3 times -2. Perfect. Are we simplified? Hint, do you only see one x? No, I see quite a few x's. So we need to combine these or simplify this somehow. Okay, so I'm going to rewrite it down here, our other step. So I see a product rule on top, right? They're all being multiplied. So think product rule, we are adding the exponents. Okay, so I have 3 right here. Plus 2 is going to give you what? 3 plus 2 is 5. 5 plus another 1 is how many? 6. So we have x to the 6th power on top. And now we just need to simplify the bottom. Okay, this is pretty easy. What is 3 times -2? Remember, what is a positive times a negative? We know it's going to be negative, right? A positive times a negative is a negative. Okay, what is 3 times 2 now? Perfect. 6. And that is simplified. Kind of drew that fraction bar really big. We didn't need it that big. Oh well. Nice job. So that is our first rule. That is negative rule. Okay, so your notes should look like this so far. And now let's talk about our second and last rule. Okay, so our second and last rule is our power to a power rule. And this might sound pretty complicated, but it's actually not, okay? So let's define it. First, we're going to define what is power to a power. So first, let's say we have x squared. Okay, so there's our first power. But now what we're going to do is you're going to see a lot of parentheses, meaning the whole thing is to a different power. Okay, and then we have our second power. We'll say it's cubed. Okay, well, let's rewrite this. Let's expand it to show what it's actually doing. Okay, x squared cubed really means x squared times itself 3 times, right? X squared times x squared times x squared. Okay, well now, notice nothing is to a power anymore. Everything is just product rule. So now we can add our exponents. Okay, so now we have 2 right here. We have another 2 and another 2. So what is 2 plus 2? 4. What is 4 plus another 2? We get x to the 6th. And technically we don't even need to write these parentheses. But I did anyway. Okay, so that's what's actually happening. But here's the quick and easy rule. Okay, when you have power to a power, you're now going to think multiply. you're gonna multiply these two numbers together. Okay, and let's try it and see if it works. So let's write it again. X squared to the third power. Okay, we're gonna just multiply it. What is 3 times 2? Great job. We see that we get the same answer, x to the 6th, right? Same answer. Perfect. So we can see that when we expand it, we get the same answer as when we multiply those two exponents. Okay, don't get these mixed up with product rule. Remember, product rule, you're adding them. 2 plus 2 plus 2 equals 6. Power to a power, quick and easy. 3 times 2 is also 6. Okay, so that's our power to a power rule. So let's practice. Okay, so notice on number 7, we see some parentheses. Parentheses means everything inside. So the first thing you're going to want to do is find that exponent on the outside. Okay, in this case, it is 3. Okay, and it's going to multiply to each exponent inside. Notice there are 2 of them. So it's going to multiply by both of those guys. So the first 2 is going to be to what power? What is 2 times 3? It's going to be 6. Okay, our second 2 is going to be to what power? What is 3 times 3? It's going to be 9. Okay, are we done simplifying? Okay, I see 2 2's here. That means we're not done simplifying. So we need to now, this is product rule, so what are we doing with our exponents with product rule? We're adding them. So now our base is 2, just like on our very first exponent day. What is 6 plus 9? Okay, now we have product rule equals 2 to the power of 6 plus 9. What is 6 plus 9? We get 2 to the power of 15. Great job. Okay, let's look at number 8. So let me ask you this. Where do you see the parentheses? Is this 4 going to multiply by the 2 and the 4? Nope. So we see that this 4 is only in front of that 4 right there. Okay, this 2 to the 4 is the only thing inside my parentheses. So this 2 to the second power, 2 squared, stays 2 squared. Nothing has been multiplied to that 2. Okay, but this second 2 right here, it becomes 2 to the power of 4 times 4, which is 16. Okay, now we're dealing with product rule again. So 2 is our base. Now we get 2 plus 16, which is what? What is 2 plus 16? 2 is going to be to the power of what? Great job. 18. Nice job. Okay, let's do number 9. Number 9 is probably our hardest one of the day. Okay, so we see that we have a 4 in front of this whole parentheses. So it needs to distribute to every single base, the y base, the x base, and the 2 base. But what invisible exponent does that 2 have? Remember, it has that invisible exponent of 1. Okay, so it has to actually multiply 3 times in there. Okay, same in our second one. It needs to multiply by the y base. The x has an invisible exponent of 1, and the 2 has an invisible exponent of 1. Okay, so again, multiplied 3 times. Okay, so let's take it step by step and figure out what they are. Okay, so let's take our first one. 2 to the power of 1. What is 1 times 4? So 2 is our base. What is 1 times 4? We get 4. Okay, let's take our x. Now we have 2 times 4. X is our base. What is 2 times 4? 8. Now we have our y. Okay, what is 3 times 4? is going to be 12. Beautiful. Okay, we took our whole first term and we simplified it. Okay, let's take our second term. Now we have 2. Okay, it's all being multiplied. Notice that dot in the middle. 2 is our base. What is 1 times 4? 4 again. Okay, x is our next base. What is 1 times 4? 4 again. And then our y base, our last one, what is 3 times 4? 12. Beautiful. Okay, now we took our second term and we simplified it. So now we need to simplify even more because I see a couple 2's, some x's, and some y's. So we need to combine them. Okay, so how we combine them is product rule. Notice they're all being multiplied. So let's take our 2's first. So I have 4 2's right here. I have another 4 over there. So 4 plus 4, what's that going to be? 2 to the power of 8. Beautiful. Okay, let's take our y's now. I'll do a different color, or x's, excuse me. So I have 8 x's right here. I have another 4 over here. So what is 8 plus 4? Get x to the power of 12. Okay, last one. I have 12 y's in our first term and 12 more in our second term. So what is y going to be to the power 2? Think 12 plus 12. You got it, 24. And there we go. I only see one 2 base, one x base, and one y base. So that is our simplified answer. Perfect. Okay, number 10, our very last problem. So you'll remember, or you might remember from last time, probably my favorite exponent rule ever. What is anything? Okay, so notice we have all these parentheses. Okay, we have a 0 out here. Okay, meaning 0 is to the power of everything inside. Okay, what is anything to the power of 0? You guys remember? It is 1. So that 0 on the outside of all of it, meaning everything inside those parentheses, means that whole thing turns into a big fat 1. Okay, and let's just make a reminder on our paper. Okay, anything to the power of 0 equals 1. Always. Perfect. Okay, your notes should look like mine, all filled out, so you can get your participation points. If you're doing this assignment from home, then this page already filled out will be linked for you. Okay, so you'll just have to do your assignment. Okay, awesome. See you guys later.